Woo! What's up, guys? Hey, Devs here. Another day, another LeetCode problem. I think this is day 28, 29. Let's go ahead and check. So we have day 27, it's 28. Notice this was over a day ago. Did not post yesterday, and I'm so sorry about that. I was doing schoolwork all day yesterday. Oh, and also 12 subscribers away from 200. I mean, who is this guy? I mean, is he famous or something? Oh, I'm very thankful for all of y'all that have subscribed and interacted with the channel. It's got way more traction than I thought it would. It's kind of hard to get views on YouTube. I guess my thumbnail hit the mark, and everyone that programs has heard about LeetCode and how it helps you with interviews and data structures. And this is like I guess like a real world example about some average guy that goes to college for computer science completing a few problems. But yesterday I didn't post. I was doing schoolwork all day yesterday. I got inducted into Kappa Mu Epsilon. We got home a little bit after 5. I worked all morning, and then I had to do notes. I mean, me and my girlfriend, we ate supper, and then around 6 o'clock, I was taking notes from 6 to 10 on I did my math notes, and then I did notes for my operating systems class. In my operating systems class, I had to read a whole chapter, and I'm a slow ass reader, so it took me a while to do. And then I studied a little bit for that class because I have a test in there Thursday. You can see the little fur ball right there, Shadow. So, hey, buddy. He's been a good boy today. He did eat recently, so I gotta take him out pretty quick. So we're gonna make this video, I mean, I'm guessing 10 to 15 minutes long. This problem is exactly like the other problem we did yesterday, not yesterday, 2 days ago. I will be making up the video tomorrow. I'll be posting two, so we're back on track since I skipped a day. Binary tree level order traversal. Given a tree, it wants us to print 3, and then put 920, and then 15.7 in a list down here, kind of like this. And then the difference is they want us to go left to right, so the node is left to right, it's just a 3. And then the next row, they want us to go left to right to left, so they want us to print 20, then 9, and then the next one is 15 and 7. So my solution for this is it's almost exactly like the solution for this problem, except we're going to use a DQ, and we're going to have a Boolean bit. It's to determine if we're going left to right or right to left, and then each time it should be in order, right? So we're going to start off kind of like we did in the last one. So we're going to create a list of integers, and we're going to call that a solution. It's going to be equal to a linked list of list integer, and we're going to new, don't forget the new operator, and then we're going to check if the root is null, because if it's null, we want to return a empty list. So we'll just go ahead and check root is equal to null, because if it's equal to null, we can't check anything anyways, so we'll just return the solution. So then we want to create our DQ. So we can go ahead and DQ. We want to hold tree nodes inside of it. DQ, we're going to just call it DQ, is equal to array new. Let's not forget the new. Okay, I can type, I swear. Array DQ. Oh my goodness. Oh my goodness. I can't type today, fellas and women. I don't know who watches me. A new array DQ, and then we want to go ahead and DQ.add last, and we want to go ahead and add our root node into there. And then we also want to create a Boolean. It's and we're just going to call it left to right, and we'll set that equal to true. So left to right means we're going to read it left to right, and then if it's false, that means we're going to go right to left. And then we want to loop while the DQ is not empty. So while it is not empty, we will go ahead and loop. Then after the while loop, we want to return our solution list. I had a sneeze and spell. Excuse me for that. I had a sneeze and spell earlier, and I have like mucus all on me right now. It is not going well. But anyways, we have our list solution. This is going to be returned with the output they want, right? And then we check if it's null, because if it's null, like it says in example 3, they want us to return the solution. And then we create a DQ, because a DQ is going to allow us to add elements from either side and remove elements from either side in the order we added them, right? So from there, we can set this Boolean to determine the order we grab the values from, right? So if the DQ is not empty, we want to create a list of integers, and this is going to hold the level list, right? Because right here on the left, this would be the second level, 20 and 9, read to right to left, and then the last level is 15 and 7, read left to right. So we're creating this level list right now. So it's a new linked list of integers, and then this is where we're going to store our level, and then at the end we're going to go ahead and add it to our solution, and in between here is where we're actually going to add the values. So we're going to create an integer called DQ size, and then we're going to set that equal to DQ dot size. And the reason we're creating the size variable is because we're going to do a for loop, and I is equal to 0, and then I is less than DQ size. And the reason we're not using DQ dot size here is because I don't want, we're adding elements to the DQ as this for loop is iterating. So I don't want the DQ size to grow or anything like that before, I don't want it to iterate too many times because our DQ is growing during this operation, growing and shrinking. So we don't want that, because we're also removing elements from the DQ and adding elements to the DQ. So our DQ size is fluctuating. We only want it to loop as big as the DQ is before it enters the for loop, right? So that's why we're going to do create the DQ size variable. Be sure to track that. And then inside here, we want to create a tree node. We want to see if we're reading it left to right. And then if we're reading it left to right, we'll do this block, and then if not, we'll do the other block. So if we're reading it left to right, this is exactly like the other problem we did right here. And if you look right here, we're basically doing this entire chunk, this 5 lines of code inside of each statement, except one is going to be removing from the head and adding to the last, and then one's going to be removing from the last and adding to the head. So if it's left to right, we want a tree node, we're just going to call this temp, is equal to DQ dot remove last, or remove first, not last. So this will give us the tree node at the beginning of the DQ, and then from there we want to add it into our level list. So level dot add temp dot value. Okay. And temp will never be null, so we can go ahead and do this, because we already checked if root was null, and then we added root, and then the only other time we're going to add it a value into it is if it's not null. So we can go ahead and check that. So if temp dot left does not equal null, we'll go ahead and add it into the deque. Deque dot add last temp dot left, and then we're going to check the right side. So temp dot right does not equal null. We'll go ahead and deque dot add last temp dot right. So this is the basic code we used for the first problem. If we go ahead and run this, it will never run the else block because we never set left to right equal to so we never set left to right equal to false, so it will never run the other side, and we haven't implemented the right to left reading. So this would work exactly like the other problem does. As you see, it wants 920 for the second level, and then down here you see we get 920. So the next thing we need to do is we need to make sure set left to right equal to the opposite of what ever value it is. So we'll go ahead and use the ternary operator. So left to right. Question mark, and then if it's true, we want it to be false, and if it's false, we want it to be true. So this is just swapping the bit. And then else, we want to basically, we can copy and paste this. Copy and paste this here, because we're doing the same exact thing, except every time we remove from first, we want to remove from last. And then instead of doing the right side, we want to, the left side, we want to do the right first. Right, and then and then we want to add it to the first. So, and where it says first, we want to put last, and where it says last, we want to put first. And we also want to swap the order we add the nodes in. So usually you do left node first, then right node for almost every problem. And in this one, we're going to do right node first, then left, and then if we go ahead and run this, there it goes. It's accepted for the first case. And if we submit this, there we go, runs in 1 millisecond. I'm not sure where the overhead is. I wonder if there is a Java solution that uses the beats 100%. Yeah, both approach, but in directional toggle. Left to right logic. Okay, that's smart. So okay, so they use an integer value instead of Boolean. They do the same exact thing, except we just copy and pasted the code based on the flip. And instead of doing that, they do the same exact solution as the first, except at the end, they see if it's left to right or right to left. And then if it's supposed to be right to left, they'll reverse the list completely and then add that list into the value. That's very smart. It saves you 6 lines of code by adding 2. So okay, it saves 6 lines of code. You still add 2, but you get rid of 8 with my solution. And it beats 100%. So we're going to go ahead and copy and paste this and see what we get. The space complexity and the space complexity and time complexity is O of n. Where the space complexity is O of 2n, so because we have a list that's the size of every node, and then we have a it runs at 1 millisecond. It doesn't beat 100%. Maybe mine's just a little. They're both about the same. With our solution, we'll go ahead and go to our submitted. Where's this doing? Copy to editor. Yeah. So our solution has a O of n time complexity, where it does it does this block of code for every level, and it does this block of code for every node, and then or one of these blocks of code for every node. So it's for sure is an ON time complexity, and then the space complexity would be 2n, which you would take off the 2 and just be O of n space complexity, where we create a solution that has as many entries as there are nodes, and then we create a DQ that's also ends up being as big as our node list, or as big as one level. But the list is, sorry, excuse me, is for sure as big as our tree. So I think this will be all for today's video. I'm not trying to do too much. I have to take Shadow out. I do not want him shitting on the floor. He knows he will get in trouble, and he wants the treats. We give him treats when he goes outside. We might not do that. That's going to get expensive after a while. But y'all stay blessed. Y'all stay healthy. Y'all stay coding. And thank y'all for all of the subscribers, the likes, the comments. I love reading y'all's guys' comments. Some of y'all are doing the same thing as me, trying to do problems every day. Some of y'all have gotten tech jobs, and some of y'all have put 1,500 applications in and still haven't got a job offer. And you've passed many different tests. I mean, that's awesome to hear, but it's also scary to hear how competitive the tech job space is. But I'm hoping we're going to break through one day, and this is kind of my roadmap into there. I saw comments today on my phone asking why I haven't applied for jobs yet. The simple answer is I haven't had time to really look at it or figure out where I want to go. The more complex answer is, or the more truthful answer is, I don't have a resume. I need to make a resume. I need to talk to if you go to school, your resources at school will help you build a resume. I need to talk with them, try to figure out a good resume, and then I need to create a project or 2 projects to add on there that can show that I can actually program, that isn't created by ChatGPT, or copy and pasted. They don't like seeing similar projects to other people, right? So they want something decently unique that people use and it's useful to people. So I want to be sure to do that. And then the LeetCode is just so we pass the technical interview part of the interview, because most of the time tech jobs, you go through 4 or 5 different interviews, and each one they will test you on different data structures and algorithm problems. That's what LeetCode helps you for. You definitely don't need to do LeetCode to pass those problems. It definitely helps you refresh and learn different niche data structure and algorithms problems. Most of these you should be able to solve, like medium problems. If they take you more than 10-15 minutes, you might need to try an easier problem of the same subspace, and then hard problems shouldn't take you more than 20 minutes, and same with easy problems. Easy problems shouldn't take more than 5 to 10 minutes. That's kind of like my thought process. I watched a couple of LeetCode videos. He has a great YouTube channel. He explains LeetCode. He has solutions to almost every valuable LeetCode problem there is, and he's helped a lot of people get jobs and pass the technical interviews. But all I'm going to say is I haven't started looking yet. I need to start looking. Speaking of the comment, school is kicking my butt right now. We're starting to get into exam time, so it's cram time also, while I'm trying to keep this YouTube channel up. If I took my efforts out of the YouTube channel and put it into the job search, I probably could do that. But I have been enjoying making these videos for whoever's watching them, y'all guys. And yeah, that's basically all I want to say. Is I'm gonna work on it. Thank you for the reminder. And when I do get my resume together, I'll probably make a video on me building my resume, because this whole channel is about me trying to get a job. So we're going to try to put that together and then post on YouTube kind of how I built my resume. And then I will also, once I get the results back from interviews and different applications I put in, to see how well my resume does. And then if we tweak it, we'll also see how well that one does. It's all a learning experience and to be a tool and a resource to help other people out. But if you made it this far, thank you again. I was rambling the past 5 minutes now. But y'all stay blessed, stay healthy, stay coding. Hey Devs is going to be out of here. I'm going to chill with Shadow and play my game. Y'all take it easy. Bye bye.